Have you ever felt the need of a detailed steel estimation report generated for your entire 3D structure? Obviously, yes. From tendering to material procurement and fabrication, everywhere this information are required. Also, total steel quantity plays a vital role in structural optimization to select the most economic section which can resist the applied load safely. But it is very hard to get the required details directly from STAAD. Though we have specified all the information during model generation, still most of the required section details are not mentioned in the estimation report, like the plate details for any built up or tapered section, without which the estimation is incomplete. Do you know how to automate this process and get all the details in a single report easily from any existing steel structure? Hi, my name is Surajit Ghosh, and in this video, I'll talk about steel takeoff. For any type of steel structure, how we can easily check the used steel quantity for cost estimation and tendering purpose, how to filter the member details like length or critical ratio for both fabrication and steel optimization using a custom template that I'll cover in this video. I'm sure you will find this tool very useful for your project. But before going into the details, first I want to discuss about the default option available in STAAD to extract steel quantity. I'll talk about the input and output of these options and also point few problems. Well, if you used these options before in any of your project, then I'm sure you are quite aware of these problems. Still, I want to discuss these issues and then discuss how easily we can overcome this using the custom template. In this video, I am going to use this PEB structure. This is a warehouse type building, and as you can see, I have used several tapered beam and column sections in this model, along with few user-defined wide flange section and circular tie rods. I want to get the steel quantity for all the members and for a group of members. Also to optimize the structure based on this report. If you want to know more about this structure or how I have generated this model using various tapered and user-defined sections, how different loads including crane load and design parameters are assigned, then you can follow my upcoming series on PEB structure. Instead, under steel design command, two options are available to extract the steel quantity. First one is the member takeoff and next is takeoff command. By the way, I have already discussed about rest of the commands in my previous video series on steel structure optimization. If you want to know how to use select or select optimized command or even the group command, then you can go through the steel optimization series available in my YouTube channel. These two takeoff commands are not exactly same. Both can extract steel information, but the level of information that is extracted is different. Takeoff command extracts only the steel quantity for each section assigned to the selected members. For example, if we want to extract the total steel quantity of the whole structure, then we can simply assign this command to all the members. And we need to analyze the model to get the steel quantity. This is the first and most irritating problem. If we want to get the steel quantity for different portion of the structure, each time after assigning this command, we have to analyze the structure. And you know, this steel quantity is not even dependent on the analysis results unless select command is used for optimization. It just depends on the assigned section and length of the member. Still, we have to analyze the model each time, and for a large structure, we have to wait hours to get the steel weight. This is what I dislike about the default takeoff commands. After analysis, in the output file, total steel quantity is reported for all the sections that are used or assigned. As you can see, in the entire model, 12 different sections are used, and for each section, total member length and weight is reported. These values are calculated considering all the members with same section. For tapered section, as there is no separate title, a member number is included in the section name to separate one section from another. That's all. No other information about the member or section is reported here, and this information is not adequate for estimation. For any built-up section, normally the flange and web plates with required thickness are purchased, and then those plates are used to build the sections inside. That's why for built-up sections, we are more interested about the plate details rather than the overall weight. But that information is nowhere mentioned in this table, and only option is to calculate it manually. This is another major problem of steel takeoff command. We can also use the member takeoff command. Say we want to get the steel quantity of individual member for a part of the structure. We can assign this steel member takeoff command to all these members, analyze again, and after analysis in the output file, we can get the steel quantity. As you can see, first the overall steel quantity for each section is reported. This is similar to the steel takeoff command. Total length and weight for each section is reported here. And if a section is not assigned to any selected member, then that will not be reported in this table. Along with this, a detailed report is generated where for each selected member, section, length, and weight is reported. Surprisingly, in this table, the tapered section names are not modified like before. We can use this table to get an idea of individual member length, but we need to find the members with same section manually from the entire table, which is time consuming. Also, it is extremely difficult to get the information about different tapered sections. All sections seems alike, right? How can we understand these sections are same or different and accordingly filter the member lengths? These values are reported in the default unit system, and to change this unit to kg or metric ton, we need to specify the unit before any of these commands. I normally prefer to specify this from the input editor. Once again, we have to analyze the structure to get the quantity in modified unit system. These are some of the major problems that I noticed during handling some of my large steel design projects. Most painful is to get the detailed information about the built-up or tapered sections. If we can extract the flange or web plate details along with the weight of different plates used in the model, then we can easily use the data for estimation and material procurement purpose, right? In reality, either we have to calculate the plate details manually or depend on some third-party or in-house applications. What if I provide you a tool which can address all these problems in a single click? Yes, we can extract the steel quantity along with the section details for rolled as well as for built-up sections in a single click and customize the data as per our requirement without even analyzing the model. I have generated this user tool using several OpenSTAAD functions as there is no direct function available to extract the takeoff information. This is very powerful and fully customizable. First, check the inputs. We can extract the steel quantity for any member or a group of members, and that member information can be specified using various methods. Like we can use all the members present in a model or select all the members with a specific material. If we have a composite type structure like the columns are concrete and top roof portion is steel, then we can filter the steel members using this option. There are two other options. We can select the members in a STAAD model and then use this option to get the steel quantity only for those members. And finally, we can specify a group name and steel quantity for that group will be extracted from the STAAD model. This option is very useful for any large model as we normally create several member groups for load or property assignment, and we can use the same group for takeoff report generation. In this model, I have created several groups and I can use any of these groups for takeoff. For example, this tapered member group, we need to specify the name of the group only. Next inputs are related to the level of information that we want to include in the MTO file. If there is any built-up or tapered section or hot roll section with cover plate used in the model, then we can extract all that information. Currently, I have implemented only white flange section along with tapered section, but I can easily extend this to consider other built-up section like channel or tube. We can also include the property reference ID, member count of each section, and total volume in the report. If this information are not required, we can easily exclude from the report. For first example, I want to include all information in MTO. Also, we can generate the steel quantity report for individual member, including the critical design ratio. This is very interesting, and I will discuss this later. Finally, we can select the unit of weight like kilonewton, kg or metric ton and select whether we want to format the report sheet or not. With these inputs, we can generate a complete takeoff report in a single click. Say we want to generate the steel quantity for all the members present in this PEB structure. Simply click on this tab and see, within few seconds, all the information is extracted from the STAAD model. Let's check the output. First, the section information is reported. We can easily identify different tapered sections using the reference ID. These two tapered sections are not same as the reference ID is different. This ID is the reference number mentioned in the property table, and we can easily identify and cross-check the details from the STAAD model. Total number of members for each section is also reported. We can use this information for breakup details. And finally, we have the steel quantity report. Total length, weight, and volume of each section is mentioned here in specified unit. These two columns are also reported in STAAD, but volume, reference ID, and member count are not available in the STAAD report. Next, we have the plate specific information, which is very important for any built-up section. In this table, I have exported the flange and web plate information for any built-up or tapered section. Remember this option? For each section, the top and bottom flange width and thickness are reported. Like this tapered section has a flange width of 250 mm and thickness of 16 mm. First number is the width and second number is the thickness. Similarly, for web, the start and end depth along with the thickness is reported. This web has a start depth of 322 mm and end depth of 422 mm with thickness 8 mm. For uniform depth wide flange section, single depth is reported. Note that this is not the overall depth, rather the actual depth of web plate. Along with this section information, the plan area of flange and web is also reported here. Plan area means total length of the member multiplied by the width. This will provide an idea of the plate that is required to build this section. Isn't it useful? For any built-up section cost estimation or fabrication, plate details are mandatory, and using this table, we can easily get all the information related to any user-defined section used in the STAAD model. Not only this, I have also included a summary. First table reports the total steel quantity, overall length, weight, and volume of all the sections used in this model. This includes both rolled and built-up sections. And second table provides the area and weight of each plate with relevant thickness. As you can see, plates with different thickness are used in this model. We can get the details from here, like 10 mm plate is used here and 14 mm plate is used in this section. And the total quantity is reported in this table. We can use this overall area and weight of individual plate for estimation and procurement. If we know the unit price of each plate or the rolled section, we can specify that right here, multiply that with the weight and get the total cost. This is an Excel report, so we can customize it or use the data as per our requirement. If you are working on any steel project with built-up section, then I think this report will help you a lot. There is another page, MTO report for individual member. Before we explore this page, consider this scenario. This built-up I section is assigned to 6 members, and I want to know the plate length for each member. Length of each member might be different, and for procurement or fabrication purpose, we need to know the individual length of flange and web plate. How we can get this information? One way is to check the STAAD model and note down the length of each member manually. Not a good option. If there are hundreds of members, then this manual process is both time consuming and prone to error. I have a better solution. Check the individual member report. In this page, details of each member used in this MTO is reported, like member number, section, length, and weight. Forget about the design ratio as of now. I'll come back to this later. We can use this table to know the actual length of each member or filter members according to section. For example, we can easily switch on the filter and then select only the S column section. With this, length of each member where this section is assigned is only visible. So we need to inform the fabricator or vendor that we need two sets of plates with length 1.5 meter, 2 meter and 3 meter each. Easy, right? We can also copy paste this data to other files. Say I want to know the individual length for this tapered section with reference ID 1. From the member detail page, I can isolate the section with title Taper 1 and all the member lengths are listed here. We can use the filter option to isolate and get the member details which is required. Now I am curious to know whether all these sections are passed or not. Can you get this data from STAAD.Pro report or even from your report file? I don't think so. In this template, I have included one option using which we can extract the critical design ratio for each member. This time, I am going to extract the steel quantity for these members. Change the method to selected member. Switch on design ratio option. Rest of the inputs are same. As I am not analyzing the structure, so this tool generates the complete report within few seconds. I have tested this code with a very large model with more than 5000 members, and it only takes 15 seconds to generate this report. In the first page, details are provided considering only the selected members. The total member count and weight is different this time. In the member detail page, along with section and weight of each member, the critical design ratio values are reported. Obviously, we need to design the members first, else no ratio will be reported. I have color coded the value so that we can easily identify the members which are failed. Like this member has a ratio greater than 1. Same for this section. I need to change the circular rod and tube section. Assigned section is not adequate. Can we also check where these members are located? Yes, we can. That's why I have included this tab. Just for an example, we can switch on the filter and isolate the failed members using color or using the number filter. Display only those members which has a ratio greater than 1 or 0.9. These are the members which failed, and now we can simply click on this tab and go back to the STAAD model. See, all these members are now highlighted in the GUI. We can further check the reason of failure from the design report and accordingly modify the section of these members to optimize the structure. This filter and highlight option are very useful to check the member alignment. Like we can isolate the circular section and then highlight to check the orientation and alignment of these members from the model. We can also use the group information to generate MTO. This time, I want to extract steel quantity and section details for this tipper member group. Specify the name here, and it is now generated. We can check the plate summary, flange and web details, weight and design ratio of this group. Also, this report is very accurate. I have compared the extracted results with STAAD report using several models with different sections, and it is a 100% match, as you can see here. This report is generated for all the members present in this model, and same figures are reported by STAAD in the output file. One final information. I have considered the center to center distance of each member to generate the MTO. The actual member length is different from this due to different types of connection. If you consider any beam to girder or beam to column flange or any bracing connection, the actual member length is less than the center to center distance. But I don't have any connection data to calculate the actual length of a member. So this is not considered in the report. The variation is very small and we are in the safer side. That's all. What do you think about this template? Do you think this might be helpful for your projects? Let me know your thought about this tool or if you have any suggestion. Thanks for watching.